Chemical bonding. Let's review mixtures and pure substances. Now, if you'll recall from Unit 1, we talked about mixtures and pure substances. So let's take a look. Pure substances are just compounds or elements, like sodium and chlorine, which makes salt, or H2O, which makes water, and helium and nitrogen are examples of elements. Mixtures are just a mix of pure substances. So if we take the two compounds, salt and water, and mix them together, we get salt water. It's a mixture. So with mixtures, you can have a mix of two or more compounds, or compounds and elements, or two or more elements. Valence electrons. Valence electrons are electrons in the outer energy level. Now, why would I have an E with a minus? Because electrons have a negative charge. How can you tell how many valence electrons an atom has by just looking at it? Well, we can't actually see an atom, but we can look at the periodic table. So if we look at the periodic table, we would look at the group number. Have you ever made a cake where you mix together water and flour and sugar and some other stuff, or maybe your mom or your grandma did, and placed it in the oven for a while, and out came something entirely different? Well, this is an obvious chemical change. So why would I say it's an obvious example? Think of all the different examples or different things that we could look at to see if there was a chemical change that occurred. You'd have the smell of it. You can always smell a cake baking. You have a color change, all right, because you have the golden brown on the top, or black if you burn it, okay. You also have something completely different when it comes out. The heat of the oven, the wet ingredients stick together with the dry ingredients, and eventually becomes so that you cannot separate them anymore. In other words, it changes bonds of existing compounds or makes new bonds with different elements. So, what exactly is causing the ingredients to stick together? A chemical bond. It is an attractive force that holds atoms or ions together. Now, ions isn't a completely new term to you, but I want to go back and review it a little bit. And this is not on your paper, so you may have. On the website, I am going to have these video links, so I'm not going to show these to you right now. But I would like for you to go back and watch especially the first one, What Are Ions? So it'll be a really good one. And also the properties of ionic compounds and what are ionic. Okay, so I lied. I decided I'm just going to make a different video about ions that way. We can go on with something, we can continue on with this one, and you can watch the ions. So why do these bonds form? For a chemical reaction to occur, bonds have to be made or bonds have to be broken. So most of the time we're going to be looking at least right now, why bonds form, why they come together. Remember, atoms want peace. A lot of times I refer to it as they want to be happy. They want to get that full valence electron shell. Remember those 8 electrons that I talked about? Well, that is called the octet rule. So let's look at this figure here. We see that we have 3 atoms here, and let's see how they're going to satisfy this rule. You've got an electron here in hydrogen, electron here in hydrogen, and in oxygen you have 6 electrons in the outer shell. Well, It has that second outer shell, so it needs two more. Hydrogen only needs two electrons because it just has the one shell. Remember, it's the one that's kind of the oddball, it and helium, because it has just that one energy level. So when we look here, you can see that water has bonded and you end up with 8 electrons now in the oxygen, but you also have 2 in each. So we're going to look at some types of chemical bonds. We've already looked at one, kind of a basic one. So we're going to go into a little bit more detail. Now throughout the next week, we'll be going into more detail in additional videos. Now the first thing I'd like for you to do is to take a look at these sodium and chlorine elements. I want you to get out your periodic table and I want you to determine if sodium and chlorine are either metals or nonmetals or a combination. So go ahead and pause the video, get out your periodic table, find and locate where sodium is and where chlorine is. Well, hopefully you found those, and pause the video and realize that sodium is a metal on the far left and the nonmetal is chlorine, which is on the far top right. When a metal and a nonmetal come together, the bond that forms is an ionic bond. Ionic bond. And remember, you're going to be watching that video here in a little bit on ions. Notice the coloring I did of that. That is just to be able to give you a good visual. Now, on number 2, you can't necessarily see which elements these are, but let's say they are sodium, and this is the nucleus of a sodium. And it is surrounded by the electrons on the outer edge. It's kind of neat about this kind of bond, and it actually is called a metallic bond. And that is because you will have 2 metals or the same metal that ends up being attracted to each other. And the reason metallic bonds can cause electricity, they're really good electricity conductors, is because these electrons are able to kind of float around and they're able to pass an electronic charge, which I think that's pretty cool. So when you have a metal to a metal, then it is called a metallic. The third one I want you to look at, I'd like for you to use your periodic table again and find hydrogen and oxygen and determine if hydrogen and oxygen are metals or nonmetals or a combination. So pause it, pause the video and take a look, locate and determine if you think hydrogen or oxygen is a metal or a nonmetal. Now I know hydrogen is on the far left, but remember hydrogen's that one oddball up there. It is the only non-metal that is located on the far left. And oxygen, if you remember where the metalloids are, those semiconductors, oxygen is to the far right, so it is a non-metal also. So you have 2 nonmetals. These 2 nonmetals, when they bond together, and this is the one that we looked at a little bit earlier with oxygen and hydrogen forming a water molecule, it's called a covalent bond. This is called a covalent. So the definitions that I'd like for you to write, and these are just kind of quick summaries: ionic, metal bonds to a nonmetal; metallic, metal bonds to metal; covalent, nonmetal to a nonmetal. So go ahead and jot those down on your notes. Now, the first thing I'd like for us to do with this is just to remember, if you have a nonmetal plus a nonmetal, what type of bond that makes. So think a minute. If you have a nonmetal plus a nonmetal, that would be a covalent bond. We'll go to the easy one. If you have a metal plus a metal, gives you a metallic bond. So what do we have left? You have a nonmetal plus a metal. That will give you an ionic bond. So to do these sample questions, what I'd like for you to do is use your periodic table, because that's what you'll need to be doing for your homework and for your worksheet, and determine if you have a metal and a nonmetal, a nonmetal and a nonmetal, or a metal and a metal. So do that first, and then you can easily come back in and see if it's a covalent, if it will form a covalent, a metallic, or an ionic bond. So let's take a look at the first one. You have sodium and you have chlorine. So pause the video and determine if sodium is a metal or a nonmetal, and if chlorine is a metal or a nonmetal. And then come back and check. All right, sodium is a nonmetal and chlorine is a metal. And so then you would end up with a ionic bond. Good job. All right, go to carbon dioxide, which is carbon and oxygen. Find those on the periodic table and come back and check again. Both are nonmetals. If you have two nonmetals, that would form a covalent bond. All right, now you have chlorine gas. So there are two chlorines that are bonded together. So determine what chlorine is. Pause the video if you need to. If you have chlorine plus a chlorine and they are both nonmetals, you have got a covalent bond. Copper and zinc, which makes brass. And find those. Those may be a little bit more difficult to find, but I'm sure you can find them. So just pause the video. They are a metal plus a metal, and that forms a metallic bond. Sulfur and fluorine, find those on the periodic table. Pause it, pause the video. A nonmetal and a nonmetal, which makes a covalent bond. Aluminum, that is a metal plus a metal, which is a metallic bond. Now, you are going to be responsible for a quiz over this tomorrow. So please be sure and make sure you understand everything. Go back and watch these videos again. Let me torture you a little bit more. And then go on to take a look at the ion video, please.